In this video, we're going to be taking a look at a container known as a chain map. And what a chain map enables us to do is essentially encapsulate many dictionaries into a single container which returns a list of dictionaries. So to use chain map, we first of all need to import it, so we'll put from collections import chain map, and then we'll set three very simple dictionaries. So we'll put D1 and set this equal to a dictionary where the first key is A with a value of 1, and the second key is B with a value of 2. We can copy and paste this dictionary, and then we can relabel D1 to be D2. We can set the first key to be C with a value of 3, and the second key to be D with a value of 4. We can then copy and paste this dictionary. We can relabel the variable to be D3, then we'll have the first key to be E with a value of 5, and a second key to be F with a value of 6. Now creating a chain map is very simple. If we now create a variable called C and call upon the chain map class, and then in parentheses pass in the three dictionaries that we've just created. So if we put D1, D2, D3, when I now print out what's stored in variable C, you can see that we're presented with a chain map object, and in parentheses we've returned three different dictionaries. But we can actually access the values in the same way, just utilizing key names. So if I were to print the value that's associated with key A, so if I put print brackets C, open square brackets, and pass in A, you can see that we print to the screen value 1, which is exactly what we would expect. Now we can also access the values and the keys utilizing the values and keys methods. So if I just print some dashes to separate the original chain map object, and then loop over the values from this object. So if I put for I in C.values with parentheses, if I now just simply print out I, you can see that we print out 5, 6, 3, 4, 1, 2 to the screen. And that's every single value in this chain map object. Now the reason it's not in order is because obviously a dictionary is an unordered dictionary. It's not ordered like the ordered dict, so it's in a slightly random order. Now we can do the same but with respect to the keys. So in a new code cell, if I put for I in C.keys and then print out I, you can see that we print out E, F, C, D and A, B to the screen. Now if you wanted to access both the key and the values at the same time, you can obviously take advantage of the .items method. So you could put something like for A, B in C.items, then parentheses. We could print A and then print B. And this would enable us to access both at the same time, just like a standard dictionary would allow us to do. Now the final thing I want to share with you with respect to chain map is the fact that we can add new dictionaries to our chain map once it's been established. So if I set a fourth dictionary called D4 and set this equal to a dictionary where the first key is X with a value of 8 and the second key is Y with a value of 9, if I create a new chain map called C1 and set this equal to a call on the old chain map, so C, and then put dot and then access the new _child method and then put parentheses. Inside the parentheses, if I now pass in the D4 dictionary and then run this code cell, you can now see that when I print what's stored in C1, we get a new chain map object, and the dictionary D4 has been added in this view to the start of our unordered dictionary. We can now access the values, we could access the keys just like we've seen in the prior example. So if you ever run into the use case where you need to stitch dictionaries together and have them treated as if they were one dictionary, then the chain map container from the collections module could be the perfect option for you to utilize. In the next video, we're going to take a look at another collection known as named tuple. So I'll see you in the next video. In the last video, we introduced the concept of lambda functions, which are simply functions that we define with a number of parameters. We include an expression, and we can then assign this anonymous function to a variable, which then stores this lambda function object. Now we can use lambda functions in conjunction with other functions that take in a function as an argument. And the first function we're going to look at is the filter function. Now the filter function is a built-in Python function. So if I type out filter and then put a set of parentheses and then take a look at the documentation that supports this, you can see that the filter function takes in a function and then it takes in an iterable. And you can see that we will then return an iterator yielding those items of iterable from which function is true. So what does this mean? Well, basically, this means the first parameter will take in a function, the second parameter will be an iterable, so a list for example, and then when we run this, each item in the iterable will be sent into the function, and if it evaluates to true based on the expression, the result is returned. So let's see an example where we have a list and we'll call this num_list, and inside this list we'll store integers from 1 to 10. So this will be our iterable and we're going to pass this as the second item in our filter function. Now the first parameter is a function, so I'm going to define a function, and my intention here is to filter out the even numbers from this list and return those even numbers as a new list. So I'm going to put lambda and then num, which is what I expect each of these items in the iterable to be passed into when we run the filter function. I'm then going to put a colon, and then I'm going to put in brackets num modulo 2 is equal to 0. So this is my expression, and therefore when we pass in num into this expression, it's either going to evaluate to true or it's going to evaluate to false. So when I run this code block, you can see that it relates to a lambda function with a single parameter called num. So what I can now do is use my filter function and pass in these two lines of code into the respective parameters. So if I put filter and then open a set of brackets, I can copy and paste my function code and place it as my first parameter. I can then put a comma, and the second parameter I can include my iterable, so I can simply type num_list. Now if we run this line of code, you'll see that we bring back a filter object with its respective location in memory, which is obviously very difficult for us to see the result, but as we've seen earlier in the course, in order to convert this into a list, we can pass this into the built-in list function. So if I wrap this in the list function, you can see that when I press return, we do indeed bring back 2, 4, 6, 8 and 10, which are the even numbers from our num_list. And we could then assign this to a variable called even_nums, and then we can then use this list in subsequent parts of our code. So hopefully not too tricky to understand. The filter function is a function that takes in two items. The first item will be a function, and this is where the lambda function is a good option. The second parameter is an iterable, and for each item in the iterable, it will be passed into the function and will be evaluated accordingly. If it evaluates to true, it will be filtered accordingly, and we can then pass this into the list object. Okay, so moving on to the map function. How does the map function work? Well, it's very similar to the filter function. But this time, what the map function will do is take every item in the iterable and pass it into the function, where the function's expression performs some kind of action. So it won't evaluate to true or false and filter items, but it will perform some form of logic, and then it will be returned accordingly. So let's start with our iterable, and we'll define this as a list called odd_nums, and we'll set this equal to odd numbers from 1 through to 15. We can then create our function. So our function in this case is simply going to double the numbers within this list. So we're going to put lambda and then num. We can then put a colon, and then our expression will be num multiplied by 2. Now we have these two bits of information, we can pass them into the map function. So we can put map, and then the first parameter will be the function itself. So we can put lambda num times 2. And then we can put a comma, and the second parameter will be the iterable, so we can pass in odd_nums. Now when I run this code, you can see that we store a map object at the respective location in memory here. So in order to convert this into a readable list, we can pass this into the built-in list function. And when we run this, you can see that we obtain a new list which doubles every number from the odd_nums list. And if we wanted to, we could assign this to a variable for onward use. Now sometimes it's cleaner to compartmentalize your code, so what you may want to do in this instance is assign your list to a variable called odd_nums and assign your function to a variable called double to give it some form of meaning. I can then delete the lambda function inside the map function and I can replace this with the variable name double. And when we run this, we get the same result. And this to many is a lot easier to see because you can then see that the map function takes in two parameters, the first one being the function, which we can see is defined above, and the second one being the iterable, which we can also see is defined above. So in this video we've seen how we can pass in lambda functions into other built-in functions such as filter and map.